Welcome back, everyone. In the last video, I introduced you to how we can depict the structure of an atom using the Bohr-Rutherford diagrams. Now I would like to introduce how can you draw the Bohr-Rutherford diagram for an actual atom in the periodic table. Please do not be intimidated by this. Once you get used to the steps that you have to follow in order to draw it correctly, it becomes a matter of habit and it will not seem as difficult as when it's first introduced. So let us start off with the simplest version, with the hydrogen atom. So please look at your periodic tables, which I hope by now you're used to always having before we start these videos. And let us work with the hydrogen atom. The hydrogen atom in the periodic table is very simple. So look at the box where the hydrogen atom is. You have hydrogen. You'll see that it has an atomic number of 1 and an atomic mass of 1. So simple. So from that, you should know that hydrogen has 1 proton. But if its atomic mass is 1, that should tell you that there are 0 neutrons in hydrogen. Because remember our equation. The atomic mass is equal to the number of protons and neutrons. But if the atomic mass is 1, and we have 1 proton, what does that tell you about how many neutrons we have? 0. So when we're drawing the nucleus of the hydrogen atom, there's only 1 proton in that diagram. Okay? So I just wanted to make sure that that was clear. So let's draw the Bohr-Rutherford diagram for hydrogen. We just determined that there is 1 proton. There are 0 neutrons. How many electrons are in the hydrogen atom? Remember the video. I explained that the number of electrons equals the number of protons in an atom because it's neutral. So that means we also have 1 electron for our hydrogen atom. Let's start drawing the Bohr-Rutherford. Always start with the nucleus, which is the center of the atom. So here's our nucleus for hydrogen. In the nucleus, we depict how many neutrons and protons are in the atom. For hydrogen, we have 1 proton and 0 neutrons. I always like to write 0 neutrons just so that I can be clear that I've already considered it and I didn't just forget to write how many neutrons there were. So as a matter of habit, I'd like it if you guys would tell me that there's 0 neutrons so I know that you've actually thought about it, you've done the calculation, and you just haven't forgotten to tell me how many neutrons are in the nucleus. So we've gotten the nucleus taken care of. We now have to talk about the electrons. I talked about shells that surround the nucleus of the atom. And we depict those as rings around the nucleus. I told you that the first shell can contain a maximum of 2 electrons. In our case here with hydrogen, we have 1 electron, which will definitely fit in the first shell. So we depict that as a dot on our valence shell. And if you want, you don't have to, you can refer to it as the electron. This electron is by itself because hydrogen only has 1 electron. We have our 1 proton and our 0 neutrons. So this is the Bohr-Rutherford diagram for hydrogen. Because we've introduced this, I'd like to introduce you to a term about the outermost shell of an atom. Because hydrogen only has 1 shell, that is the outermost shell for hydrogen. And we call that shell the valence shell. This is very important because we're going to talk about valence a lot. The valence shell is the outermost shell of an atom. And we refer to the electrons that are on that shell as the valence electrons. Okay? And I will refer to this over and over again as we do more Bohr-Rutherford diagrams. So let's step it up a notch. Let's go to a more complicated atom. So hydrogen was very simple. Let us try carbon. So look at your periodic tables, and let's try to do this together. So let's look at our periodic table and look at carbon. So carbon has an atomic number of 6 and an atomic mass of 12. So we are going to work on the carbon atom, which has an atomic number of 6 and a mass of 12. That should tell us that we have 6 protons from the atomic number. And if we have 6 protons and a mass of 12, that should tell us that we have 6 neutrons. Try to remember the calculations that we did before, because atomic mass is equal to the number of protons plus the number of neutrons, which is why we have 6 protons and 6 neutrons. How many electrons would we have? So remember, an atom has a neutral charge, which means that it should have a 0 charge. So if we have 6 protons, we said that proton number should equal the electron number. So that means we have 6 electrons. So this is the first step you should always complete before you draw a Bohr-Rutherford diagram. Find out how many protons we have, how many neutrons we have, and electrons. Then you can go about actually drawing the Bohr-Rutherford diagram. So, I mentioned you always start with the nucleus. And what do we write inside the nucleus? The number of protons and the number of neutrons. So in this case, 6 protons, 6 neutrons. We depict that in the nucleus. Here comes the tricky part. Well, not really tricky, maybe just for the first time. We have 6 electrons. So let's draw the first shell. Here we go. Here's our shell. How many electrons did I say that this first shell can have? 2. Maximum of 2 electrons on the first shell. So let's put 2, because we have 6 that we need to take care of. So we have 1 electron here. And remember I said we like to do pairs. So we put another electron here. We've only shown 2 electrons. What happens to the other 4? We have to draw another shell. So here's shell number 2. Now pay very close attention to what I do now. When we have to do shell electrons, we don't pair them up right away. We take turns. So we put 1 electron here, 1 electron here, 1 electron here, and 1 electron here. Okay? We take turns before we double up. So count with me how many electrons we have now. Okay? So if we count, we have 1, 2, 3, 4, 5, 6. So our Bohr-Rutherford diagram has 6 electrons, and that matches the electrons that we need. This is the outermost shell. So we will call this the valence shell. How many valence electrons do you think we have? So count how many electrons we have in our valence shell. 1, 2, 3, 4. So carbon has 4 valence electrons. That is how we do the Bohr-Rutherford diagram for carbon. let us even go a step further, and how about we try silicon? Okay, so let us try silicon, which is in the same group as carbon, but you will notice that its Bohr-Rutherford diagram changes. And hopefully you'll start noticing a trend in the Bohr-Rutherford diagrams as we go down a group. So look at your periodic table and let's look at silicon. So I'm looking at my periodic table. We have silicon having 14 protons and an atomic mass of 28. So silicon has 14 protons. If it has an atomic mass of 28, that means it must have 14 neutrons. I'm hoping by now how you get those numbers are clear, considering we've done them many times before. And how many electrons do we have? Same as the protons, and that should be 14 electrons. First step when it comes to drawing a Bohr-Rutherford diagram. 14 electrons, quite a bit. So let's see how we're going to draw the Bohr-Rutherford diagram. What do we start with? The awesome nucleus. And we will write 14 protons, 14 neutrons. Now let's start working on our electrons. Draw the first shell. Here we go. Can contain 2 electrons. So we can take care of 2 of our electrons here. How many electrons do we still need? There's still 12 that need to be taken care of. So we will draw our other shell. So remember how we do the electrons on our outer shells. We will have to do single electrons before we pair them up. So we start with 1, 2, 3, 4. Now, can the second shell only hold 4 electrons? No, we said that shell number 2 can have a maximum of 8. So we can add more because we still need more electrons. That is when you now start pairing them. So you go around again and you pair those electrons. Let's count how many electrons we have in total. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Do we have the right amount? No, we are still missing 4 electrons. So we now have to draw the third shell. Okay? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are still 4 electrons. Remember, do not pair them yet. You do 1, 2, 3, 4. Okay? Do we need to pair them? Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we do not need to go around again and pair them because we have our 14 electrons. So this is the Bohr-Rutherford diagram for silicon. We have our 14 protons, our 14 neutrons. We have 2 electrons in the first shell, 8 electrons in the second shell, and 4 in the third. So, as a reminder, we call the third shell now the valence shell. And how many valence electrons does silicon have? Well, you count how many electrons are in the valence shell. 1, 2, 3, 4. That means we have 4 valence electrons for silicon. If you saw what we did for carbon and now what we did for silicon, you will see a trend that occurs in the periodic table. As you go down a group in the periodic table, the number of shells goes up. Remember, carbon only had 2 shells. Silicon had 3 shells. So as you go down a group in the periodic table, the number of shells increases. And that's a very good trend to remember for the periodic table. Okay, so I hope that made sense to you. Remember, please do not be intimidated by it. The more practice you do, which we will do lots of in class, the better you will get at it. And next thing you know, you'll be able to do it in your sleep.